Question 18. 50 milliliter of a 0.1 m copper sulfate solution is electrolyzed for 12 minutes at a current of 0.06 ampere. If copper is produced at one electrode and oxygen at the other, what will be the pH of the final solution? For HSO4 dissociating into H plus ion and SO42 minus ion, K dissociation or dissociation constant is equal to 1.3 into 10 to the power minus 2. Now the value of K for the reaction H plus SO4 2 minus forming HSO4 minus, the value of K will be equal to 1 by 1.3 into 10 to the power minus 2. Equivalents of copper liberated will be equal to Faradays of electricity, which is again equal to Q divided by 96500 coulombs. Value of Q will be equal to I into T. Value of current is given as 0.06 ampere. Time is given as 12 minutes. Therefore, putting the values, equivalents of copper will be equal to 0.06 into 12 minutes, and multiplying this by 60 will give the time in seconds. Dividing this by 96500 coulombs will give equivalents of copper ions, which is equal to 0.448 into 10 to the power minus 3 equivalents. Now moles of copper will be equal to equivalents of copper, that is 0.448 into 10 to the power minus 3 divided by valency factor, that is 2. 2 is the valency factor of copper. Now this is equal to 0.224 into 10 to the power minus 3 moles. We know the moles of copper and we know the volume of solution is equal to 50 milliliters. Therefore, the concentration of copper ions equal to moles of copper, that is 0.224 into 10 to the power minus 3 divided by volume of solution in liters. The volume of solution is given in milliliters. Therefore, the volume of solution in liters will be 50 into 10 to the power minus 3 liters. And this is equal to 4.48 into 10 to the power minus 3. Therefore, concentration of copper ions discharged is equal to 4.48 into 10 to the power minus 3. Now, equivalents of copper discharged is also equal to equivalents of H plus ions. Therefore, equivalents of H plus ions will also be equal to 0.448 into 10 to the power minus 3. Now, H plus ions are there in the solution because of the reaction that can be written as H2O, 2H2O, which dissociates to give 4H plus ions plus oxygen gas is evolved plus 4 electrons. Now, equivalents of H plus ions present in the solution is 0.448 into 10 to the power minus 3. Therefore, moles of H plus ions present in the solution will also be equal to 0.448 into 10 to the power minus 3 because valency factor of H plus is 1. Now the concentration of H plus ions in the solution will be equal to moles of H plus ions, that is 0.448 into 10 to the power minus 3 moles divided by volume of solution in liters, that is 50 into 10 to the power minus 3 liters, and this is equal to 8.96 into 10 to the power minus 3. This is the concentration of H plus ions in the solution. The concentration of sulfate ions in the solution will be equal to 0.1 as it was in the original solution. Now in this equation, where H plus ion combines with SO4 2 minus ion to give HSO4 minus ion, the initial concentration of H plus ions is 8.96 into 10 to the power minus 3. Concentration of sulfate ions is 0.1 and initially the concentration of HSO4 minus ions is 0. Now if X moles of H plus combine with X moles of sulfate ions, then we can write the final concentration of H plus ions will be 8.96 into 10 to the power minus 3 minus X. Final concentration of sulfate ions will be 0.1 minus X. and the concentration of HSO4 minus ions will be X. The value of K for this equation will be 1 by 1.3 into 10 to the power minus 2. Therefore, we can write 1 by 1.3 into 10 to the power minus 2 is equal to X divided by concentration of H plus ions, that is 8.96 into 10 to the power minus 3 minus X into concentration of sulfate ions, that is 0.1 minus X. Solving this equation, the value for X is equal to 0.00788. Subtracting the value of X, the concentration of H plus ion in the solution will be 0.00108. Now pH of solution is equal to minus log H plus ion concentration, which is equal to minus log 0.00108. And solving this, the pH of the solution is equal to 2.96.